Hello everybody, welcome to the first ever tutorial video that we will be doing under the Edu-Malanga Mathematics tutorial video series. Today we will be looking at the first topic for Matric syllabus in South Africa, and that topic is patterns, sequences and series. By the end of the discussion of the topic, we will hopefully be able to understand and work through problems involving arithmetic sequences. Before we get too much into the mathematics of patterns, sequences, and series, let's begin by taking a look at patterns, sequences, and series and understanding how they affect our daily lives outside of them being in mathematics. So the most common pattern that everybody on earth encounters every single day of their lives is the pattern of the rotation of the sun. The rotation of the sun is a pattern because it takes place every single day and it's a 24-hour repetitive cycle. So after 24 hours, you return back to the same hour, and because it's something that happens that way all the time and there's no changing it, it's a pattern of some sort, a natural pattern. The next pattern that I can think of that is South Africa specific is the voting patterns of South Africa. The way we vote in South Africa is a pattern because, for example, we go to national elections every 5 years. If we look at the 1994 election and see that as the first term of the pattern, then from 1994, if you add 5 years, you're going to have the next national election, which is in 1999. And as you keep adding 5 years, every single 5 years, you know that you will end up having an election year. So that is a pattern. The last pattern is language. And we use language every day in order to communicate with other people, but we don't actually realize that it's also a form of a pattern. Language essentially is a pattern because there's 24 letters in the alphabet, so those are all the terms A to Z, and we learn how to use these alphabets and interchange them with each other in order to create words, and then other people understand us. So language is a pattern as well. Now that we've looked at examples of how we use patterns in our everyday lives, let's get started on the mathematics of patterns now. The first pattern that we look at, as I said at the beginning, is the arithmetic sequences. Before I get too much into depth, let me also just make everyone understand that sequences and series are actually forms of patterns. So when we speak of patterns, we are speaking about the broad picture of everything covered under this topic. But as we go along, we'll be able to understand what exactly is the difference between sequences and series. And for now, let's get started with the arithmetic sequence. We're first going to derive the arithmetic sequence. After the derivation, we're going to then look at the key features of it, what makes it an arithmetic sequence. We'll come up with a word definition, and then we'll derive a general term, and at the end we'll work through an example of an arithmetic sequence. So let's get started. The arithmetic sequence that we are going to derive, the first thing that it composes of is the first term. So for example, if we use the voting patterns of South Africa, 1994, that election would be the first term of our sequence. So when you're starting every sequence, you have term 1, which is where it begins, and what we define term 1 as all the time is always A. We use the variable A to derive term 1. We need to then, to derive the next term, do something to term 1. So the next term will be term 2. We'll abbreviate and use T2. And what do we need to do to term 1 in order to generate term 2? For arithmetic sequences, what we do is we add something that we call a common difference, and we denote the common difference using the variable D. So we derive the second term, term 2, by adding d to the first term, which was a. If we were to derive term 3 then from all of this, we are going to again take the previous term, a plus d, and we have to add d to it. So term 3 becomes a plus d, which is term 2, plus another d, which is what we have done to term 2 in order to get term 3. I hope I'm being clear, but just to make the point very strongly, let's derive the last one, which is term 4. And term 4, in order to generate term 4, we go to term 3 and we say a plus d plus d. That's our term 3. And what do we do to it in order to derive term 4? We add another d. So we have a plus d, which is basically term 3. And we add another d. And now we have term 4. And that's how you derive and create the terms of an arithmetic sequence as you go. Let's make it all very simple. What are the key features that we looked at for arithmetic sequence? The first thing was we had a first term. That's important. The first term defines where our sequence starts. So if we use the voting patterns of South Africa, the first term, for example, we would use the 1994 general election as the first term, and every single time from there, the next election will come 5 years later. So from that first term, we add 5 years and we keep adding 5 years, and that's how we're able to know exactly when we will have elections in this country. So the first term is A, and the last key feature that we noted was D, which is a common difference. So these are the key features of an arithmetic sequence. Now that we've done this with one, as well as we've just noted the common features, and there's really two things to remember. You have a first term, which is always going to be denoted by the variable a, and you have a common difference, which is d. If we were to write down a word definition for the arithmetic sequence, what would we do? What would we say it is? And a very simple definition is to say an arithmetic sequence occurs when you have addition, because we added d, so addition of a common difference. Our common difference was d, as we defined it, to an initial or a first term. And our first term was the variable a. And that is how we would just use words to define an arithmetic sequence after having derived it on this side of our worksheet. There's three things to highlight in this definition. It's addition, it's the common difference d, and it's our initial or our first term a. And those are the three things to note when we are speaking about arithmetic sequences. Let's go on. So now that we've derived this sequence, say for example someone was to ask you about and say, what is term number? Because as we were going, we were discussing terms. We had term 1, term 2, term 3, term 4, and we kept going. What if someone were to ask you, what is term number 50? What would you do? How would you derive term 50? Would you keep adding and do term 5 and add D's forever? Or is there a simpler way to find term 50 of this arithmetic sequence? There is a simpler way to do this, and the simpler way that we use is what we call the general term of the arithmetic sequence. The general term. Because we've been using variables, what we're going to do is we're going to derive a general term, and we're going to introduce one last variable that we will use in this topic, and that's the variable Tn. N represents the term number, so N is equal to our term number. What's important to note about N, there are some restrictions about it. If we go back to our sequence that we derived ourselves, we'll know that N starts at 1, so we don't have a term minus whatever. So N will always be a positive number, and we'll also note that it's also a whole number. It's 1, 2, 3, 4. It's not 1.6, 1 point whatever. So those are the restrictions to note about N, which is the term number. It's always positive. Apologies, let me erase. It's always positive, and it's a whole number or an integer. Positive integer, that's the word for whole, the mathematical term for whole numbers. That's what N is. And now that we've introduced the variable N, let's come back to see how can we use these variables on this sequence to derive a general term for arithmetic sequences. So when we look at the first term and all of the terms that follow, we'll notice that A is always there. You always have A plus something, however many D. So the general term will have A plus something. We now need to understand what is the relationship between N and D. So when we look at the first term, which was term 1, we'll know that there was no common difference there. It was just A. When we look at the second term, we'll know that there is now D. We've added one D only. We've just added one of the Ds. So what is the relationship between this and that exactly? And for you to get 2 from 1, you basically have to say 2. Maybe you have to divide by 2 and then you get 1, or maybe you have to subtract 1. Let's see if there's going to be a pattern that we're going to see between the relationship between this number and however many D we have there. So for term 3, what happens is you have 1 and 2 Ds. So you have 2 times D. Okay, so there needs to be a relationship between 2 and this. Let me rewrite this to 1. Yes, there's a relationship between 2 and 1. There's a relationship between 3 and 2. Let's look at 4 lastly. 4, and you have 3D, because there's 3, 1, 2, 3 Ds. So what's the relationship between N and the multiple of D? It looks like when you have, for example, term 4, right? What you need to do is you need to say minus 1, and then you end up with 3, which is what you see there with the D. And when you have 3, again, you basically only have to say minus 1 again, and you're going to end up with 2 times D. So for 2, let's see, for 2, if you say minus 1, you end up with 1D. So the relationship between N and D seems to be like this. You have N minus 1 times D. And what we have right here after this derivation is the general term of an arithmetic sequence. Now that we have that general term, let's maybe get into a quick example just so we make sure that this information settles in our head and that we have understood it fully. The example that we're going to look at is a very simple arithmetic sequence, and here's how it goes. You have 3, 7, 11, 15, and 19. So what were the common features that we noticed? We have a first term and a common difference. Maybe let's ask ourselves, what are those for this sequence? So what's our first term A equal to? A, we can quickly read it from the sequence, is equal to 3. Nice and easy to read. Check. What is our common difference D? And the way in which we derive D is by subtracting the previous term from each term of the sequence. So let's get started. In order to find the common difference, we say 19 minus 15, and we have the number 4. And we say 15 minus 11, that is also equal to 4. 11 minus 7, that's also equal to 4. 7 minus 3, that is also equal to 4. So our common difference between the terms of the sequence is the number 4. Now that we have A and D, can we come up with a general term for this sequence? So Tn, the general term for this sequence, is going to equal, very simply, if we just use substitution, we need A, which we've already solved for, was 3. So Tn is going to be 3 plus, and then because we're using n minus 1 times D, which we solved for as 4, times 4. Oh, easy enough, right? Okay, that is the general term of that sequence. The next question now is, what is term 21 of this sequence? What's the 21st term in this sequence? And if we were to use the relationship between n and d, we're going to say, for term 21, if we substitute 21 into where n is, we're going to say term 21 is equal to 3 plus 21 minus 1 times 4. And that's equal to 3, if we use BODMAS, brackets off first. So what we do is we simplify what's in the brackets so we can get rid of them. 3 plus 20 times 4. And now we do the multiplication first. 20 times 4 is 80 plus 3. So term 21 of this equation, of this sequence, is equal to 83. Pretty simple, right? Yes, and then the last thing, second last question, apologies, is the number 119, right? What is it going to equal to? Term what? If you have 119, how do you solve for the term that it is? So to solve for this, the first thing that we do is we just come back to our general term for this equation that we've derived. It's 3 plus n minus 1 times 4. Let's rewrite it. Tn is equal to 3 plus n minus 1 times 4. That's our general term. So term 119, what's it equal to? And what we simply do is we substitute 119 into the final answer because we know what the answer should be. We just need to solve for what n was. So we say 119 is equal to 3 plus n minus 1 times 4. Now we're going to have to solve this equation, and when we solve equations, we know that we start by grouping like terms. So we're going to group the threes. Whatever we do on the left side, we have to do to the right-hand side of the equation. Sorry, that was bad. Geez, I don't know left from right because I'm actually left-handed. What we do to the left side of the equation, we have to do to the right side. So we're going to start off, if we're grouping like terms, by getting rid of the 3. So it means we must subtract 3 from this equation. So we say minus 3, and we also have to do it that side, 1 minus 3. And we have 3 minus 3, so the 3's are going to cancel out. 119 minus 3 is equal to 116, which is equal to n minus 1 times 4. Then the next thing that we're going to do, let's rewrite the equation. 116 is equal to, open brackets, n minus 1 times 4. So what we're going to do next is we have to divide by 4 then. Divide by 4 and divide by 4, because what we do to the left side, we have to do what we do to the left side, we have to do to the right side, and we're solving for n. 116 divided by 4 is equal to 29. You need to use your calculator to do this. Is equal to, and the 4's cancel out, n minus 1. So what we do is then we add 1 to this side of the equation and we add 1 to there, and in the end we have n is equal to 30. Therefore, term 30 of this sequence, is equal to 119. Easy peasy, right? Last question now. If we have the term 48, so now we have 48 as a number, what term number is it in the sequence? Again, that's the question. And we know how to solve those kinds of questions. We simply do what we've done for the previous. We say 48 is equal to 3 plus n minus 1 times 4. Okay, and we subtract 3 and we subtract 3 from this side. 48 minus 3 leaves us with 45, and then we have with n minus 1 times 4. Then we divide by 4 like we did before because we're solving for n, and then 45 divided by 4 is equal to 11.25. Wait. What we have is equal to n minus 1. So because we have a fraction, right? Remember what we said about n when we derived the general term. We said this term number can only be a positive whole number, guys. So when we come back to this, because it won't be a whole number, what we can say is that 48 is not actually a term in this sequence. So 48 does not belong in the sequence. You won't find it if you keep going and adding 4, which is the common difference, and adding 4, you won't have the number 48. That's what that simply means when you find a fraction in that instance. Thank you very much for watching this video. I hope it has been educational for you. The next video we're going to do further examples on arithmetic sequences so we can make sure that it settles in your heads, and hopefully you'll stay with us as we keep working through the math syllabus for Matric in South Africa.